We are in our math book, and this is topic 2. So we are looking at topic 2 in our math book, and I am on page 86. So find page 86, and we're going to go through these examples together. We'll do the try-its together as well. So looking at our essential question here, how do you solve equations that combine like terms? Now I know this is done for you in the examples, but if there's anything that I underline or highlight or circle, I would like for you to do the same in your book. So here we're looking at combining like terms to solve addition equations. And this example is showing us that Gianna has 36 yards of fabric. That's the total amount of fabric she has. And it says that we can make matching placemats and napkins. We know that the placemats are 1 1/3 yard long right here. And we know the napkins are 1/6 yard long. So you can see our bar diagram that if we have the 1 1/3 and we add it to the 1/6, that's how much we need for a set, for one set of placemats and a napkin. For one placemat, one napkin, that would be considered a set. And we know we have a total of 36. So we combine those, and we can see that they went through the solving process to find out if I've got 36 yards of fabric, how many sets can I make of placemats and napkins? We're going to look at a very similar problem here with our try-it. So let's go ahead. I'm going to go to the next slide. We're going to walk through our try-it. So in our try-it, it says Selena spends a total of $53.94 to buy a necklace and a bracelet set for each of her friends. So each of her friends gets one necklace and one bracelet. Each necklace costs $9.99, and each bracelet costs $7.99. How many necklace and bracelet sets, that's what the S stands for, did Selena buy? So if we're looking at this, we know that each friend is getting a necklace. How much does the necklace cost? The $9.99. There's an S there. And each bracelet is going to cost $7.99. And you're going to find real quick, this one doesn't bother me, but you're going to find real quickly, I do not like these boxes. I feel like they do not help us in these situations. There's many times I cover them up with a sticky note and write my answers on a sticky note. So $9.99 plus $7.79, and those both have the letter S. They have the same letter. They're like terms. We can combine those and add those together. And when you add those together, you get $17.98. So what that means is it costs $17.98 for a bracelet and a necklace together, which is a set. And we want to know how many sets do we purchase for friends. And so if we have $17.98 times S, I want you to think of that as times. What is the inverse operation to get S all by itself? Well, we need to divide both sides by $17.98. And when we take $53.94 and divide it by $17.98, we find that she buys 3 sets of necklaces and bracelets for her friends. Okay, let's look at this convince me. Suppose the equation was, and they just changed the equation up. The question here is, can you combine the S terms in the 4.6? So my question is, can I combine all of those? Think for a minute. No, you cannot. No, why not? Because the 4.6 does not have an S. It is not a like term. So we've gone through example 1 in the try-it. We're actually going to go to the next page now. I'm going to go to page 87 in your book. Remember, you need to get this written down. There's plenty of room for you to write this down or highlight. if I highlight something. We're going to skip it. We're going to go straight to example 3. And here on example 3, it's saying, can we combine like terms with negative coefficients to solve the equations? The coefficient is the number in front of the letter. Guys and gals, yes, we can. We know how to do this. Use a calculator, change all your subtraction to addition, and just combine them. And don't be afraid of decimals. That's why we can use our calculator. Okay, so we know how to change subtraction to addition, and we can just combine these. So this is example 3. We're going to move on to the try it and do it together. Again, I'm on the bottom of page 87, looking at the try it. And here, here I have 2 problems. And yes, one of those problems has a fraction, and yes, the denominator is not the same. So we're going to have to go through a lot of steps to change that. Let's go ahead and look at A. Okay, first of all, I'm going to rewrite it as a negative 1/4 D plus a negative 2/5 D equals 39. We have to have common denominators in order to add fractions. That bottom number has to be the same. So I'm going to multiply this entire fraction by 5 over 5, which means I really multiplied it by the number 1, which means I didn't change the value of it. 5 times negative 1 is negative 5. 5 times 4 is 20. I don't think I gave you any fractions on your assignment, so let's not be too concerned about it, but it's a good review. My other fraction, we need to multiply both by 4, so we're trying to get this common denominator. So I have a negative 8 over 20 D, and that equals 39. So now that we have now that we have changed our fractions to have common denominators, we can go ahead and add them. We can just add a negative 5 and a negative 8 is a negative 13 20ths D equals 39. And now, in order to get the D all by itself, this would be a great example of we want to multiply by the reciprocal. We want to flip this fraction and multiply by the reciprocal. The reason is because 20 times negative 13 and negative 13 times 20 is just going to leave me with a 1D. And on the opposite side here, we can make 39 into a fraction by placing it over 1. And 39 times 20 is 780. And 1 times negative 13 is negative 13. And if I simplify and divide 780 by a negative 13, I actually get a negative 60. So this is A. Yes, this probably you did not have enough room on your paper. You could always use a sticky note to put over it, or you could find somewhere up by example 3. There's some space. You could have written it up there. I'm going to look at example B, except I'm going to do a new slide just because we don't have any more room on this one. So if we look at B, yes, it's decimals, but again, we have our calculator. So I don't want us to get too concerned with these. The process is the same. Let's draw a line down our equal sign. Let's change all of our subtraction to addition. Oh, this one. We have a subtract. We're going to change this to add. But the opposite of a negative 12, if I put a negative sign there, it becomes positive. So this just becomes addition. This is a negative 9.76D plus 12.81D. Subtract means add. Why can we combine these? Because they have the same letter D. So we can go ahead and add them, and we get 3.05D equals 8.54. And now when we go to our solving steps here, we know that this means multiplication when you have a number next to a letter. And so to get D all by itself, the inverse of multiply is divide. Whatever we do to one side, we do to the other. Why? Because this becomes a 1D. Anything divided by itself is the number 1. And 8.54 divided by 3.05 is 2.8. Those decimals are a little easier than those fractions, aren't they? The very last slide I have for you, that was to finish up page 87. Again, we did not look at example 2. Okay, so to look at page 88 at the very top before you practice your work tomorrow, if you look at the very top here, we have what's called the key concept box on the top of page 88. The key concept box summarizes what we just did. In an equation with variable terms on one side, you can combine those terms first and then do the inverse operation to solve for the letter. Okay, so we are combining like terms. They have to have the same letter to the same power. You can combine those and then get the letter by itself. We'll practice and practice and practice.